Okay, I hope this is gonna work well. Now, just because I had to reinstall OBS, and I hope I got the settings right for these being smooth and whatnot. And I also reinstalled a bunch of stuff like Anaconda and things because I'm just using a temporal machine. Um, Good. So what are we doing today? I want to start something else, which is going to be like a long-term project, and I'm going to keep doing the portfolio optimization stuff. Don't worry, I know you really like it. I'm gonna keep reading also the optimization paper as well in the next videos, especially because I think there's a lot in common in here with this project as well. But so what I have in mind is since a while already, I want to build a simulator, um, but not a state vector-based simulator, but a simulator based on some other idea. And I just want to use this to prove that whether this idea works as well or not. So we'll see. And the idea is the following, right? So the idea here is to have and apologies for the awfulness of these, but the idea is to have a state representation where each possible qubit state is a node of a hypergraph or a graph. Let's just talk about graphs. For 2 qubits, it's just graphs. So here we have qubit 1 is blue, qubit 2 is red. And then like single qubit operations just work like in a state vector fashion, right? So you would have like a Hadamard applied to this qubit would turn it into a 0 plus 1. I'm obviously omitting the normalization thing here just for the sake of brevity. But then the control gates actually create or may create edges, right? And split nodes and create edges. So in this particular case, if you would apply a control node to this state, it would split and the control is, let's say, the blue qubit. It would split the blue qubit because it's in a superposition. And let's say it's a typical traditional control node, so it would split that into the two components, the 0 and the 1. So now now qubit 1 has two nodes in the graph, right? Like before it was 1 in this state, now it has 1 in these two states. Should probably keep tracking their own probabilities somehow. I don't know. We'll see if there's any technical problems with this. But yeah, and then basically what you do with the target node is, you know, you create two branches in here, and then in this branch you don't apply the X gate, but in this branch you apply the X gate. So you end up with with something that looks like this, where you know the blue qubit has it's in two possible states, but if we know in which one we are, we immediately know in which other state the red qubit is. So that's the idea, right? And if you increase the number of qubits, you're getting into hypergraphs just because a control node is basically gonna create edges that connect three nodes, right? Like the two controls and the target node. Because it's basically a sort of a kind of end condition, right? And so I want to play with these. I don't even know how I'm going to call these. Because the problem is that there is already a concept of hypergraph states. I was googling about these recently, and I found an archive paper, the quantum hypergraph states. Quantum hypergraph states. There you go. But this is it's a different concept. So here the nodes are really there's just really one node per qubit, I think, and the hyper edges are just the whatever multi-control Z gates you have in your circuit, I think. Because there's graph states, right? Which basically you have your qubits in the circuit like that would be equivalent to this graph, and then you connect where you have control Z gates. So and that would be the hypergraph notion of like these three elements are connected via one multi-control Z. these three as well, these three as well. But I think I'm not so sure. Maybe we find out that there's an equivalence there, right? In terms of my idea and this idea, but I'm not so sure this is exactly what I mean. And so I wanted to use today's video to just start the project and do all the fun stuff, which is like, let's pick a name for these and let's just try to build a prototype. I just want to build a prototype, really basic prototype in Python and NumPy. I have an idea where I would just store nodes in a dictionary and store edges in another dictionary, and I just want to try and see whether I can play with this somehow a little bit, and then eventually I want to integrate this with in Quirk. So I would like to be able to have a Quirk version. I don't know if it would implement it as in like a way to maybe I would just really go the extra mile and actually give Quirk the capability of changing the simulator. Like being able to extend the tool make it easily extendable so you can plug in whatever simulator you want. And then maybe with a drop down box or something, you can select it. But that's essentially, this is a bit of a different beast because you don't have, the downside of these is that you don't have access to the single computational base amplitudes, right? You don't have access to these numbers unless you do a translation. Yeah, but then that could be part of the extension mechanism, right? That you have to provide with a converter, like with a conversion map or something. But what you do see here is you see the entanglement more in a more clear way, right? So you see here that we have two branches. Yeah, so I'm trying to first of all do this properly this time, and I want to create a virtual environment. So I will just go to my workspace, and I mean, it doesn't really matter, I guess, but like I want to create. So if I do conda v, that should tell me what Python version this has. Hello? No, that's conda version, whatever. I want to create, but I got to give it a cool name. Come on, like conda, because I also want to create the repository today. Create and good. So how can we call this? We can call these. This is an important question. It's always the same issue. I don't want to call it the hypergraph state simulator, like HS simulator or something like that. Because it's not the same like that, and this has already been taken. Like it's not like an MPS, for example, right? Like matrix product state. So it's a quantum hypergraph states. I don't wanna take that name. Although the name hypergraph is just cool. How could I call these? I could call these. It's about entanglement, right? It's about like really entanglement being the first citizen in here. Because a state vector is a state vector, so that's kind of like the state vector simulator. It makes reference to the data structure, which is the vector. State hypergraph, no. Hypergraph states, a hypergraph, or maybe entanglement. I mean, it doesn't necessarily have to be to simulate. You don't necessarily have to see entanglement, right? But then it's just a pretty boring graph. If there's no entanglement, it's just a bunch of nodes, and that's it. How could I call it? So hypergraph states. We introduce a class of multi-qubit quantum states, which generalizes graph states. Hypergraph. Hypergraph. Maybe we should just give it a working name, right? Like I can change that later, but it just got to be cool. Maybe we can call it. I'd like to have some. Oh, this is where I studied. No, this is not where I studied. That's the UAB. That's not the good one. The UPC is the best one. The I like to use entanglement in there. An entanglement. Maybe it's an entanglement hypergraph. That's what that's how I, because really I want to have the hypergraph name in there, but I just want to differentiate it from these ones. So it's entanglement hypergraph states. Entanglement states. Entanglement hypergraph states. Because the first citizen, the first class citizen here is entanglement. So we want to have, that's what you want to do. You want to take a look at the how the entanglement actually looks like, right? How it grows exponentially and blah blah and all that stuff. So maybe we can just go with entanglement hypergraph states. So EHS. That's pretty boring though. But why not EHS? Is this taken EHS? What is EHS? EHS. Just EHS simulate entanglement hypergraph states. Is there something like that? What is an EHS simulator? By Samsung. Emergency health services. Okay. Hands-on training, maybe that could be EHS simulator. We'll just call it like that. So I think I'm gonna call the environment EHS. What is the best thing to do? EHS sim or EHS underscore simulator or EHS? I'll just EHS sim. Do I have to specify the Python version? Can I just let it pick up whatever it has? Maybe I should do this first then. What the version of Python does this have? And then, is this really that slow? Come on. What is the CPU? 10%? I think that is definitely not optimal. Ah, come on. We'll just go with. Should we go with 3.9? Probably should go 3.9. Oh, although I don't know if all these, later if I have to install circ and whatever, I don't know if those are compatible. So maybe just. Yeah, but here I don't really care. It's just a prototype, okay? So so let's just say conda create and we'll call EHS simulator or EHS sim Python 3.9 Anaconda. And maybe we can just right away go to GitHub and get that set up as well already. So new EHS simulator. So entanglement isn't it written like this? And an engagement entanglement. Is entanglement written like this? And yeah, that is definitely slow. Entanglement hypergraph states. Entanglement hypergraph states simulator. Sounds fancy. Add a README file, and yeah, I've never done this before. What license should I pick? The default copyright laws apply. if you create an open source project, I don't really want this to be open source. We strongly encourage you to include an open source license. The open source guide provides additional guidance on. Yeah, maybe this is just a prototype, so MIT license. The MIT license is short, varies the standard, allows anyone to do anything so long as they keep a copy of the license, including a copyright notice. Yeah, okay. So maybe we just should go with these. Yeah. I have no idea what I'm doing, so. EHS simulator. Create a repository. Found conflicts, come on. What's going on? Okay, cool. Really? I just want to get started. But yeah, maybe we could just start as this is being built like before installing anything. Like, I could just clone that locally and start working on the prototype, on the concept first. Okay. So we will. I think I'll just play with the Jupyter Notebook for now, before I decide what to do with these. So, we'll go to workspace, and we'll basically clone these, right? Okay, clone. And what the heck is this doing? Done. Solving environment failed. Report data from Kernel. What is this doing? It's just abort this thing. Anaconda. Create a virtual environment. Conda cheat sheet. There you go. Okay, so just Conda create name EHS simulator Python 3.9. Just go. And then source activate. Okay, no, it's the same problem. Maybe there's some issue with the yeah, but that's at least it's doing something. Maybe there's an issue with the Python versions and stuff like that. Okay, maybe I should just actually, what if I do conda and list? Is this actually now created? Is it? Did it actually create these? Or otherwise, I'll just go with Python 3.8 or something. I have no problem with these. Why is this so slow? Runtime OpenSSL. Some conflicts in here, but I don't care about that. I think I want to know what is being created. And so we are now going to the folder in here and starting a Jupyter Notebook. Or should I actually, wait a second. Yeah, I should get into the environment, right? So I should activate the environment, which is basically source activate, right? On Windows? No, on Windows is what? Just activate? Okay. Activate, what did I call it? EHS simulator. could not find it. Look, what did I just say? 3.7. So it's a 3.8. We're happy with these. "20 minutes gone already. Come on. This is slow progress." Oh, okay, done. Is it done? No, it's not done. Anaconda info envs. This is just damn slow. 11% CPU. This whole OBS thing. I just have the base environment. Proceed. Oh, yeah. Yeah. Proceed. Okay, so it's creating the environment actually. That's cool. Finally. Running out of coffee. Yeah. So basically, that's what I want to try to play with today is. Oh wait, I do not have VS Code installed. I think, or even Sublime. Doesn't matter, right? Because I'm going to use the notebook. So actually, it doesn't really matter now. Python 3.8 being installed. Okay. I guess what I'm trying to think about like how I would approach that, right? So what do I want to prototype? What do I want to prototype, to be honest? I want to have just that, and then have some tests, as in like, can I reproduce known circuits somehow with these models, simulate them, like, you know, like how would the operations look like? So probably the single qubit operations would just look like regular operations. The trick will be when I will be, for example, in this kind of case, right? If you make a Hadamard gate to the blue qubit, you have to apply to both, right? Now, as they are entangled, no, but that doesn't make any difference. Like a Hadamard here is not going to influence the Hadamard or the state in here, is it? I don't think so. It's going to change the whole structure. Like if I had a Hadamard here, it's going to increase the overall probability of measuring a 1, right? For the blue qubit. That's interesting. But still, so what would be the case? Like, is it okay? So if I would apply Hadamard here, what would I do? So okay, what it just like do? Okay, so come on, this is so slow. Yeah, probably the video output will be just crap anyway. But so does it just go like these? Oh wait, I cannot. It also affects these one, right? If I apply Hadamard to the first qubit, so that's going to be something like that. I think so, right? If I go to Quirk and I have like let's just clear all, and I have like a Hadamard gate and a control NOT, and I, whenever I do that, that's how it looks like. But if I now have a Hadamard in here, now if I pause selecting the one, this is going to be minus, which is, yeah, it's this part, it's these. So that stays isolated within the branch. If I pause select 0, it's going to be a plus. Correct. Correct. If I now add a Control Z to these, effectively what I'm doing is I'm just affecting this bubble here, this node. So I'm going to turn these into a plus, but now, because the two nodes will be the same, the branches have to merge. So I'll have to kind of have a bunch of, yeah, that I'm going to have like, that's going to be tricky how to operate on branches, right? Because now those two would merge, right? And therefore, if they merge, these branches make no sense anymore. So that also kind of merges into a 0 plus 1, so to say. So both end up in the plus state, which is true. They're both in the plus state, so you disentangle them. So for the edges to be showing and like existing, like they must be really edges. Like as soon as yeah, essentially, as soon as you merge one of the ends, then they just disappear, right? Or the whole branch gets merged, the nodes get merged. So I'll have to have like a merge branches kind of method probably. Okay, Conda activate EHS simulator. Yeah. Oh, cool. Now I see here I'm in the EHS simulator, and now I can just go Jupyter Notebook. Hopefully I have that installed in this. No, I don't have it. So yeah, I guess Jupyter, is it like this the way you do it? Or should I install it? Install. So how do I install something in an environment? If I'm in the environment and I install it in this environment, I think that just stays in this environment, right? So it's Jupyter Notebook. Install. Jupyter Lab. Pip install Jupyter Lab. Okay, just like that. Sorry. Hope I didn't mess up. Pip install Jupyter Lab for this specific environment. So many things to install, and it's just like half an hour in. It's already half an hour in. But I guess that's what I want to do. So what I want to do is I want to have, for the prototype to work, I want to basically do the following. I have to come up with a way to translate a hypergraph, an EHS state, an EHS graph to a vector state, to a state vector, so I can at least test that what I'm doing makes sense, right? Because otherwise I won't be able to prove these, that this is somehow working. So the way that I want it to work. And then I'm going to have to implement, so the single cubic gates will be easy, right? I'm going to install NumPy as well. Install NumPy. Installing NumPy. What? Here. Can't install NumPy. Pip install NumPy. Pip install NumPy. Probably that's the. Still downloading stuff. Cool. Let me make that so I can see what's going on. Whoa. Okay, anyway. So how would you, okay, so if there's no entanglement, it's easy, right? Like I think you just have to make like the sort of the tensor product or the Kronecker product of these states, and then you kind of have your state vector. Here though, I think what you have to do, my guess is you have to take every branch, do the product within every branch, and then it's like you have a because it's like you have like a not a pure state, right? So you then have to, how do you do that? Like you how do you do that? So it's either in this state or in this state. So is it just a product of those? I guess, because here, right, you would have the so for this branch in particular, you would have, it's like the plus 0 kit, right? And then on the other side, you have like the minus and the 1 kit, right? And what I should get though is I should get these 0001. No, sorry, these, right? That's what we're trying to do. No, sorry. Actually, this. Oh, I'm stupid. Let's keep that. It's just a simple addition, I think. That's not that complicated. It's these plus these. It's the sum of. Is it? Like, because that's literally what you would get. You just sum up the branches, right? Like, you have these and you have that. But how do you calculate the values of the amplitudes in here? You cannot just sum them. You should. Within each branch, all the probability should be relative to whatever's in the branch. Because we have 2 qubits in here. That's a full system stand, like that will be that should be treated as a system in and of itself. And here as well. Let's try to make something a bit more complicated. Like but still with 2 qubits. That was the other type of entanglement you could create, was this one, and with a control set in here, right? So that's also entangled. And now you have like, okay, a fancier thing. So I say, how would this look like? So this would look like, this would look like something like this. And now you basically have a 0 and a 1. And you do control Z. So you kind of have that stays like that. Not a control Z, a control X. Is that what you want to have? No, because then we don't have entanglement. So control Z. Let's keep it. Let's leave it like with entanglement. So and then you have a 0 plus 1. Cool. So and now what? So now basically you're kind of having like. So this is basically this in the state like 0, 0, minus 0, 1, and this is in the state 1, 0, 1, 1, right? Is it like this? Yeah. Assuming, no, the other way around. I'm assuming that's how you do that. So that's the rightmost qubit, and so this is 0, 1. That's going awfully slow. I hate these. Is this done or what? I should have done this off off video. Does this match with what quirk gives me? No. 0, 0, 0, 1 plus. Oh yeah, it does. 1, 0 is the only one that has the minus. Nice. So it actually it's just the yeah, you're just joining. I guess to figure out the probabilities in here though, I need to keep track of whenever I create the branches, like that the fact that this is a 50% chance of 0 and 1, I cannot lose these because that's what that's telling me is the relative importance of each branch, right? So a branch should have, so a branch, the branches should have themselves like, yeah, let me pause this for a second because I gotta go. Okay, I'm back. See if I remember what I did. This is just awful, the quality of this. This is going to be an awful video. So this worked out now. I have the Jupyter stuff here so I can start like a new notebook. And let's just get going. I mean, wait a second. Maybe I should install NumPy as well, right? Pip install NumPy. So maybe I should just, can I close these? I'll close the notebook. Close the notebook. And how can I just kill these? There you go, shutting down. So I'm still in here. So what do I do? Pip install NumPy. Just because I think it's going to be easier to handle arrays and matrix multiplication and stuff like that. I hated that this goes so slow. That's just I had to redo the setup and I kind of forgot how I had it. But I basically, yeah, I think that there is an interesting concept here to play with. So what I will probably do is I'm thinking about the dictionary and then having one dictionary for the nodes, one dictionary for the edges, and then I still have to keep for and probably a dictionary for the sort of the weights at the edge level. I think it's gonna be tricky to implement this, I think. But anyway, so Jupyter Notebook. So what are we gonna do? Let these open the notebook. Slow. This we can get rid of. And I'll probably implement functions like for the prototype. I'll just implement like a function per operator, or something like apply xgate, and then kind of give it the qubit, and that's it, right? And or just apply one qubit operation. And you just give it the matrix and then give it the qubit. And yeah, and then the control knot, that's going to be more complicated because that's going to basically, yeah, and it's going to be different, right? If we don't have edges, it's one thing. And I'll probably you have to go through all the edges. Yeah. So what's going to be interesting is the control knot, because how am I going to implement these? Oh God, how can this be so damn slow? Jesus. Maybe I can just tweak some of the stuff in here. Like, just get going, man. I had a perfect setup and I just had to, like, whatever. So I'll open another browser here for checking stuff like, NumPy cheat sheet. I should probably want to have something like that. for arrays and matrices or tenses. Kernel error? Are you kidding? Yeah, I think probably I should actually just delete this because I think it was not initialized properly. So I should create a new one. Python 3. Can probably get rid of these. Why is this kernel error? Cannot be found. Unhandled error. But is this working? Like if I just say, like, I don't know. That doesn't do anything now. D. So it's because of the environment thing. Yeah, failed importing specific module error. So why is that? Okay, maybe I just have to install these or scripts. Post install in an admin command prompt. To run init Python install report about what is this? No. Oh Jesus! Because of Python 3.8. So I should just oh, come on. Is there a version here or something like that? Because that's specific as Jupyter, so version 2 to 3, and here they say 2 to 4. Jupyter Notebook. Issue Python 3.8. Yeah, exactly, that's what I'm getting. Should I install Python 32? Had the same issue, and installing it again helped. Didn't work. Okay, pip install. Maybe just should do these. Yeah, awesome. So let me just yeah. So I should kind of close that again. Come on, just stop it. Cool. And what did it say? Pip uninstall and okay, so I gotta uninstall it and install it. That is awesome. You know, I started a stream. I started like a video. So pip uninstall Pywin32. Two to 8. Yeah, okay. So and I guess it installs some. You need to install like another version of it. Proceed, yes. But it just said install it again, so. And now pip install. Should have gone with Python 3.7. Ah, it's gonna do this 2 to 8. Okay, but that seems to work. Environment path. So you do these and then you do Python post install. Okay, that apparently fixes it. Maybe I shouldn't even need to uninstall that, but whatever. How do I know what's the environment path? So conda environment path. Not successfully installed. I don't get it why. So how do I get the environment path? But if I'm already in the users, blah, blah, blah. Path. Conda info, create a new environment. Conda list. Ah, okay, here is just if I say conda list, maybe then. Conda list. Oh, no, and then I'll just get that. Exactly, cool. So I should do. Why isn't this? Okay, oh, so here we have. There you go. Oh, what am I doing? No. Oh, workspace, okay. Oh, but it's like, no, what am I doing? This is the Control C. So this is the environment. Now I should do Python. So is that Python? This scripts. Pywin32 post install .py install. and that should fix it. Let's check. Jupyter Notebook. No, sorry, I'm going to CD entanglement. Come on, CD whatever here, and then Jupyter Notebook. Let's see if that fixed it. Come on. Die Webseite ist nicht erreichbar. Now it's starting. Yeah, so that's it's a really entertaining video, I guess. But this is it. Huh? Click here, go to Jupyter. Because that was already open, maybe. God. Why is this so slow? I don't know. Why is this so slow? It's running at these. Just go here. Oh, there you go. Cool. Now, maybe it will finally work without a kernel error. Okay, cool. No, kernel starting. Let's cross fingers. Yeah, please. Yeah, awesome. Import numpy as np. Cool. And then basically np once. Yeah, cool. That works. Okay, cool. So what do we have? So we have, again, like, oh, I'm so rusty with these. So we're going to create like a dictionary of, like, let's say 2 qubits, right? So basically, so nodes is going to be basically an NP. It's not an array, but like, how can I? Oh, cool. So just want to do at least start the prototyping. Okay. So what about we say Python dictionaries? It's just like a dictionary. So can I just like, how do I do this? It's just like a, just yeah, just like that. I guess. Okay. So I would just say da da da. So this is gonna be qubit 0, right? It's gonna have a name, and that's gonna be an array of NP array complex numbers. So how do we do this? So that's the way to do this. So what does do? NP zeros, and it's a 2 by 2. No, we want a 1 by 2. No, we actually want a 2 by 1 because it's going to be easier to keep this as a column vector. NP complex, and then we have essentially qubit 1 to be like that as well. This is really going to be a hard-coded prototype, right? So this is nodes, and then we print nodes, and well, nodes. So what? Yeah, there you go. Okay, cool. Yeah. So that's the 0 component and the 1 component. There we go. So this we have, we've got the system. So this is basically set up. So this is like set up nodes and edges. Edges. And set up nodes. And then the edges is just going to be set up edges. Actually, an empty dictionary, right? Edges. Can I just do like that? Print node and edges. Yeah, there we go. So exactly, and now let's just define the operations, right? We can actually do this here. So let's make a how to make a function in Python with def or something. Python functions. Is it def functions? So you do like probably def, right? Yeah, my function. So apply apply gate, right? And we're gonna have the qubit name, and we're gonna have the matrix, right? Or the gate, like the actual gate. Let's call it matrix. Cool. And yeah, and so basically what this is gonna do is what's more, you're gonna give it the nodes. I'm just gonna or they're gonna give it the system, right? That's nodes. You're gonna need the nodes and edges. Then you tell it the qubit and the matrix, and what that's gonna return is gonna return nodes and edges. How can I return multiple values in a function? Or it's as easy as saying system, and basically what you're gonna have is so setup system. So you're gonna have system is just a dictionary where you get nodes, there's nodes and edges, these edges. So we're gonna have a system send here, and then this is gonna then return a system. So yeah, so that makes sense. Now, what we want to do is, for example, what we want this to do is we want to say could. So we have a qubit. And that is wrong. For qubit 0, we can have multiple elements like that. So we're going to just create a... That is really just going to be actually a list. The same here, right? Yeah, because we can have multiple, but we'll just initialize it to 1. And so what this is going to do is it's going to go and say, okay, so states is basically going to be, or it's going to say for each, I'm for state in system nodes qubit, right? So that's going to give me a bunch of states. Basically, apply gate, right? I think that's all what the gate, like what the single qubit gate, this is, you know, it's a 1 qubit gate, right? So that's all what it like does. I think it shouldn't care. Like, okay, so apply gate. So the idea is you should do like probably apply gate, and then after applying gate, you probably want to check for merging branches and whatnot, but we're not going to care about these right now. So so an applying gate is just basically, so we apply the gate. And so what this does is it, so it takes the state, so new state equals the state, right? is it just so do we want to do the state is going to be these, so what we want to do is basically matrix. What is it that we want, that we want the dot product, right? I keep missing, not the dot product, so there's just the product that what we want. Dot product. That's what we want. I think that we're like, because we're summing up the stuff, so I think we just want the dot product. So we want to np dot, and basically what we want is the matrix times the state. And that gives us a new state, and this new state is then basically assigned here, right? So how do I do this actually? Or I just like basically new states, right? It's just an empty list. And so what we do is new states equals append list. Can I just do that? Appending to a list like this. Append. Do append. And it is actually appended, right? So I should just do just basically append new state. And so at the end, what we do after this is new states, right? And we return the same system, yeah? Oh, we return this system. Cool. Let's just now have here some gates. For example, what about we do like a so the X gate, for example, is an array. It's basically of 0, no, 1, 0, right? And 0, 1, is it? And of D type and be complex, and the Hadamard gate is basically, what's the Hadamard gate matrix? I think these two will be enough now for the quick test. So it's just 1, 1, 1, minus 1. So 1 is square root of 2. So it's these, and what am I doing? So it's these, minus these, yeah, right? So if I just print X and H, am I missing commas in here? I'm just that stupid. Invalid syntax. Y. Oh. Field elements must be 2 or 3 tuples. Got 0. Sorry. Actually, I forgot to wrap this up into a bigger array, obviously. and now SQRT is not, because it's probably np dot what's missing all over the place. So these, and these. Yeah, there you go. Cool. So we have that. Cool. So now in theory, what I could just do is I could say, well, print system, right? So print system. So that tells me these. And if I just do now, for example, S2 is like apply gate, and I gotta give it the system. I say I want Q0, and I want the harmonic gate, right? And now I want to print S2. That didn't work well. Okay. So what is it doing here? Apply gate, new states. So do I want to first print new states? Oh, 0, 0, 0. So do I want to print here the new state? Dot matrix and state. So what is state first of all? And what is matrix? That makes sense. So it's not the dot product what we want. Oh, I'm stupid. It's not the, sorry. That's an invalid state. That is actually, what you want here is you want these and you want 1, 0 and you want 1, 0. That's obviously the initial state. Yeah. So, and yeah, let's see. Shapes 2, 2 and shapes 1, 2. That's not the dot product what we want. We just want matrix times state. Is it all one? No. Why not? 1, 0. Shapes 1, 0. Let me think for a second. That's arrays. That's array. That's array. But that's not what we want. We really want the np dot thing matrix state. So we have now, there you go. Cool, that works. And if I say, you know, now basically apply these to S2 and apply another hardmark, and this is S3, and I print S3, should go back to 0, but if I just say apply these two, then I've got these and that. I like it. Okay, that's good. That's good enough. So we have something now. We have 2 gates implemented. We can implement other gates. So that works well. What happens? Okay, so now the next thing would be to implement the branches, the branching, right? But that's more complicated, so I'm gonna leave that for the next video. That's at least it's the scaffolding. Well, let's check if this works for. Let's check if this works for like. I know that's wrong, but I want to have like. So 3 possible states in here. Yeah. So I want to have. Oh, what have I done? Sorry, guys, that's not what I meant. I meant to have these, and then to have these. So how can I print? So Python print pretty. Print dictionary, okay? Pretty print dictionary. Import print. JSON. Format, what the hell? function like that, define pretty. Okay. So let's try to do that. So insert cell below. So okay, that's not super pretty anyway, but like Q0, Q1. So it applies it to all of them. That's important. Yeah, okay, cool. What if I tell this not gate to be, yeah. Wait a second, something's wrong in here. Yeah, well, that is the identity gate. Yeah. The not gate is this one, right? There you go. Okay, cool. Perfect. Yeah, I'm going to leave it here. At least I have the scaffolding. So I have an apply gate, and the next is going to be apply. So apply a controlled gate, right? So that's going to basically have a system. So it's going to have a system, a control, a target, and then the actual gate. And I'm going to call this gate as well, and just basically call this gate. Gate. So that's going to be the same. So you're just going to have like a return system, right? So, okay, cool. And that's what's going to create the branching, right? And then I guess what we'll also need is we will need something like, merge branches, which basically after any of these, it checks for branches that need to be merged and kind of merges them. And what we want to also have is a two-state vector, and we also want to have a from state vector, and we have here an actual state vector. State, whatever, state vector, and returns a system. So it will initially just return, something like that. So I'll just kind of basically, it will make like something like that and return it like an empty system from state vector. Maybe I can just, I could just, to be honest, get rid of these and say, system from state vector. Just give it like an empty array. It doesn't matter for now. And then would this still work? Yeah, that works. Cool. Because it's just giving an empty one. So, okay, cool. I like it. So we have the gates in here from state vector to state vector. That's like to do, and that's also to do, and that's also to do. Cool. I'm gonna push that. Do I have? Where do I have these? I only have. Let me open up another Anaconda prompt. Yeah, well, that was just basically a long video for just some lines of code, but like, what can I do? Oh, I gotta create the repo actually. No, I have created the repo already. I'm stupid. Come on. Hey. CD workspace. CD git status. Git add everything. So I'm just gonna commit these as a Jupyter prototype. Skeleton, okay? Git commit. And git push. And so while this is being pushed, I'm gonna go to projects. Can I make a project? So Create a project. Yeah. Project board names. So prototype. That's going to be just a prototype first. Project template. What do we want? Basic Kanban, automate Kanban. Yeah. So create a project prototype. It's the first project. So what we have is oh god, it's really that complicated to do automation, move your cards. I want to have yeah, I think I'll do that later. It's just it's a long enough video, I guess. But is this pushed or what? That's definitely not pushed. Hi. Anyway, yeah, I think I'll stop the video here. See if I can push this. But yeah, that kind of a thing. That kind of a thing makes sense for now. Yeah, then we'll see. Just a prototype. Okay, that's just ugly for now. Yeah, perfect.